addition together. They might look a little weird to you because there's not 3 terms. Usually you're used to seeing something that said x squared plus some coefficient in front of x plus leftover numbers. For this section, there's just the x squared, and then all of them seem to be a minus sign, and then there seems to be a number. So before we go through it, let's list some perfect squares. 6 squared, 6 is my favorite number, 6 squared, 36. What about 5 squared? 25. What about 10 squared? 100. And what about this interesting thing, 1 squared? Well, that's just 1. Those are the things we're going to keep in mind as we go forward and factor polynomials that seem to have a missing term. Here we go. Our first one is x squared minus 36 with no middle x term. We're still going to use FOIL. We're going to look at this last term and we're going to notice that it's a perfect square. So as we populate the binomials, this is definitely going to be an x and an x. The thing that I notice is that 2 numbers multiply to be a negative number. One is going to be positive, one is going to be negative. And the key to these is to eliminate the middle term. You're going to have to add 2 things together that cancel each other out. I'll do the first one, 6 and 6. Let's look at the middle term. When we multiply this together, we get 6x. When we multiply this together, we get negative 6x, and the middle term cancels. That's what makes these so interesting. X squared minus 49. The x's go here. The positive 7 and the negative 7 multiply to be negative 49. It's that easy. Done with this one. We changed a sum to a product. The next one, x squared minus 1. X and x goes here. Plus 1 minus 1. The middle terms cancel. I want you to look at the next one, x squared plus 1. This is not the difference of 2 perfect squares like the first 3 examples were. This is the sum of 2 perfect squares. I don't want you to get confused on this one. I want you to keep this one totally separate in your mind. From what we know before, x times x gives us the x squared term. 1 and 1 definitely give us the last term. But the problem here is that symbol. If we tried to give both of them a plus, we end up with a middle term, 2x. If we tried to give both of them a subtraction, shoot, we still end up with a middle term, negative 2x. So the thing you have to remember about this is when you see the sum of 2 perfect squares, you can't factor it in Math 097. You'll learn some tips and techniques in Math 169, but at this point in our math career, we're not going to talk about imaginary numbers. I think that's enough information for you to go back to homework number 4 and complete the problems.